Hello everyone, thank you for being here and thank you for organizing this interesting track. So my presentation will complement what we have heard until now, and it will touch another aspect of the problem. There will be no clicks, no data, no worries about privacy, because we're setting ourselves in a place where we try to develop a product. So we don't have any clicks, we don't have any logs, we don't have any readily available data sets. How do we do? What can we do about it? How can we proceed? And generating synthetic data is one way that can get us going. So I'm Georgios Balikas, I'm a lead data scientist at Salesforce. I'm very excited and passionate about text mining, machine learning, and natural language processing. So please reach out if you want to discuss more about it. I will be talking today about synthetic data generation for natural language understanding with probabilistic context-free grammars. 3 parts in this title that I will be explaining deeply, hopefully deeply in the next 10 minutes of my presentation. Synthetic data generation. I'm defining synthetic data generation as a cheap way to generate massively data to train a deep neural network. Natural language understanding is a downstream application. I will be discussing about name entity recognition, which is an information extraction problem very frequently discussed as NLP and natural language understanding. Probabilistic context-free grammars. It's the gist of my presentation, the tool that I will be using to construct such data. So let's get to it. I'll not give you enough time to read this. It's just a forward-looking statement of Salesforce, and it essentially says, please don't make buy decisions for Salesforce based on the content of this presentation. I'm obliged to say this. The brief outline, we're at an applied conference, so we'll start with an application. What's name entity recognition? I will be referring to this as NER. What is a Pcfg, probabilistic context-free grammar, and how we can combine the two to get cheap data. So NER, what is it? Essentially, we try to understand the text, and NER is the task of locating and classifying text spans in unstructured text. Think of paragraphs, document, or very short tweets into a list of predefined categories. What we see here is a very realistic example of a query that we support as Salesforce Search. Salesforce is a CRM platform. Users upload content, and this is organized in opportunities, accounts, cases. And opportunities, when you try to reach an agreement to sell a product, it starts from new, and then as discussions proceed, it goes through different stages. So many opportunities for last 3 months in San Francisco, United States, about Amazon Inc. There is a typo here. United States is supposed to be a country, not a state, and apologies for this. So in this particular text span, there are some pieces of information, consecutive words, that are of special interests when it comes to a CRM application or when it comes to an application of your domain. Opportunities, an object. Imagine that this information that you upload is organized in a scheme. Opportunity is a particular table. Last 3 months, it's about time. San Francisco is city, United States is state. City and state, it's about location in general. Amazon Inc. is here an organization. So we get such type of data, and then we train a machine learning model. There are different types of machine learning models that solve NER. I will not detail them, CRFs and neural nets. It's not part of the presentation here due to time constraints. What we need, though, to train this data is data, a lot of them preferably, and data that are in domain. Why? There are publicly available academic collections of such data sets for NER, CoNLL, for instance. You may have heard it. But, well, it's not on your domain. If you're in the medical domain, in a particular language, you're developing an application, it's very strange that you'll find a publicly available collection that really resembles your need. So you need to construct such a collection yourself. 2 ways to do it. Go, sit down, and label data. Half of the team leaves the room. Or find another way that is cheaper so that you can get this data. And this is what this talk is about. Just to summarize my claim here, we need to be able to generate custom NER training data for the domain-specific models of the applications that you are building. And yeah, we have this need. What do we have? Also, we have some domain knowledge. We know how this data can look like once the product is online. Why? Well, it's domain expertise, or you have a product manager that describes a product and it gives you some guidelines. And what is Pcfg is like a creativity tool that you can use to control aspects of this data. So PCFGs have been used to model text, text in English, text in French, in different languages. It's a simple model, and what I'm showing here in the left part of my slide is like a toy, a very simple Pcfg grammar that can generate a very small parts of English language. What we just need to observe here is that there is a starting point. It's denoted with S here. So every generation will start from S, and these scores here are probabilities. Since we start from S, always the probability that we will visit this rule, essentially we will start from this rule, is 1. And the language is very simple, so we start, and then there is a noun phrase and a verb phrase. A noun phrase can be 3 different things: adjective noun, determinant noun, or simple noun. Again, you have probabilities, and probabilities are important because we're traversing these rules. And then for simplicity here, the verb phrase is just a verb and a noun phrase. See that the noun phrase is part of the verb phrase, so again, when we will start generating noun phrases, we'll have to revisit these 3 rules. What can we do? We can generate data, essentially. So we start from S, and then we sample. Well, first we are going to sample a noun phrase and then a verb phrase. And the noun phrase with some small probability that happens to appear in the figure here will be just a noun. And you can imagine that the same thing is happening for a verb phrase here. It will become a verb and noun phrase. And here, the second time that we are sampling a noun phrase, it will be a determinant with a noun. Good. So what this gives us is that noun and determinant and noun, and then you have some dictionaries about what a noun is in English: potatoes cooked in oven. Okay, this is a very silly example, but it's just here for demonstration purposes. Well, all good. Syntax is there, vocabularies are there, and here is what I'm trying to do. I'm trying to show you the link with your in-domain application, your in-domain training data. Since you have some domain expertise, and we have some domain expertise of how this product that we're building looks like, and again, here you observe that this is the query from the initial slides of my presentation, well, we can model it in a very simple grammar, and with experience, this simple grammar always becomes more complicated. But well, we can say that, listen, there is always a prefix, an object, it's about CRM, so opportunities, accounts, stuff like that, and the suffix. The prefix can be something about action: show me, list me, give me, return me, things that humans use to express an information need. And then there can be a person. Then there is an object. Here, for simplicity, only 2 objects appear: opportunities or accounts. And then the suffix can be either location or time. And the location can be a sequence of city, state, country, or city, state, or city, country, all the different combinations that you can imagine. It's very easy to enumerate this. A computer will do this. Okay, you just write the grammar, and an LTK will save your days. So you know how the grammar looks like, and you know how to sample tags, noun, verb, determinant, noun from your domain grammar. This would mean action, object, time, preposition, city, and so on and so forth. And there comes slot filling. You have all these valid tags. You just need now vocabulary that you care about. Vocabulary usually comes in publicly available lists, or you can construct it. Action verbs, I just enumerated some. Persons, there are tons of person collections out there. Organizations, tons of organization collections out there. And you can bring together vocabulary collections listed for various tasks on your domain dataset. And then you go through each slot. Action is a slot, object is a slot, and you apply sampling from these vocabularies. They can come with probabilities, and you fill them. And so you can generate realistic queries like: show me opportunities from last 3 months in, is a preposition, San Francisco, United States, about Amazon Inc. Given sufficient collection of vocabulary terms, you can imagine that you can generate a ton of them. You can introduce misspellings. You can introduce abbreviations. You can really play with it to make it more complex so that the collection can inform the model to learn stuff that you care about. Now, I will conclude my presentation, and I'm happy that I'm in time. The key message here is that for natural language understanding and natural language processing in general, There is a need, always there is a need to create custom data that respects some properties. Here these properties are represented by probabilities that you handpick yourself or you get tuned once you get logs. Frequently there is domain knowledge, and if you're working on a domain, you know stuff about it that you can express in the form of the probabilities. So Pcfgs allow this type of expressiveness, and they can be used to create data massively. I mean, creating millions of data points, millions of sentences with these grammars just takes 1 minute or 2 minutes in a laptop. So the majority of your time will be spent on training a model that can learn such stuff. This is not something that I've imagined, so we have used it to get a product from zero really in production, and it works quite well, as in fact we never had the need to use logs to fine-tune the product because our NER system learned what we wanted sufficiently well to perform well according some online metrics that we followed. More details about this product and this type of design methods can be found in the paper that I'm listing. I'm happy to take any questions if you have, and thank you for being here for this talk.